All right, here we go, ladies and gentlemen. We are looking at the last section of the first chapter here, combinations of transformations. My understanding is the last video I made a mistake, so I'm going to make another one. Hopefully won't make another one a mistake, but I'm making another video. Might even be better than the last one, who knows. So, first of all, what we're looking at is this basic sort of model of what a transformation looks like, all the transformations together. Okay, so we've looked at them individually. We've looked at vertical stretches, horizontal stretches, sliding left and right, moving it up and down. Okay, and even yesterday we looked at the last section, or the previous section, which was inverse functions. Flips it over that y equals x axis. Okay, so we've got a bunch of things going on here. If you can see that these two things, the f of x is still on the inside here, and this a and d are on the outside, so they are affecting the y value, which means they're affecting the vertical thing. They stretch it vertically, compress it vertically, or slide it up and down. Okay, these ones on the inside, the b and the c, they affect the x value, so they're horizontal transformations. Okay, they stretch it or shrink it vertically, or they slide it left and right. Okay, we're going to look at these separately. First of all, we're going to look at vertical transformations, which affect the y value, and these are the a and the d. A and the d, not the b. A and the d values in your transformed function there. And the vertical stretch is the first thing we're going to look at, which is the a. So if your a value is greater than 1, so it could be 2, right? So for example, 2f of x, right? That means that it's been vertically expanded by a factor of a, or twice as big. So all your y values double. If it's between 0 and 1, so if it's, for example, 1/2 f of x, that means that your y values get halved. It's a compression, so your y values are half of what they were when you look at an xy axis, okay? The third thing here is if you have y equals negative f of x, which would be a -2, -1/2, -1, whatever. What that means is that your y values now become negative, so it flips from up here to down here, okay? It's a flip over the x-axis. Now, let's look at the next vertical transformation, which is considered a vertical translation, which is a slide, right? We move it up and down. It's the d value at the end here. Hopefully you're understanding that if it's +2, the whole thing goes up 2. Even if it's a -2 or any negative number, it goes down those d units, okay? So this is the a and the d. The outside, they are the vertical transformations, okay? Next thing we're going to look at is the horizontal transformations. They affect the x value. And if you look at the letters there inside, it's the b and the c that we're looking at affecting horizontally, okay? We'll look at the horizontal stretch first. And just as we've seen in the past, right, the x value is a little bit different than the y because it acts kind of in an opposite sense, which means here that if your b value is greater than 1, then you have a horizontal compression of 1 over b. So if you have f of 2x, right, that compresses by 1/2. And then similarly, if you have f of 1/2 of x, that's a vertical expansion of 2, so you flip it on the inside, okay? It's a little counterintuitive, but you do enough of them and you'll remember. And the same thing happens if it's less than 0, okay? What we have, it means that your x values have become negative, which means you have a flip over the y-axis, all right? Now, if we look at a horizontal translation or a slide, you've dealt with this when we did quadratics. And it looks a little bit different. Again, it's kind of counterintuitive, opposite to what you would think, because if your c is greater than 0, so for example, if you have x minus 2, what this is actually, it's like saying f of x minus a plus 2, because if you look at the original thing here, okay, this is the original thing, the standard notation is putting a minus here. So if you have x minus 2, it means your 2 is actually positive. Okay, so it goes right 2, okay, or right c units. And similarly, if your c is less than 0, it's going to look like this. It's actually going to be a plus. Why? Because it's going to be x minus a minus 2. So your x's your c is negative, it's less than 2, but it looks like in this function as an x plus 2. All right, so it's a little bit weird. If your c is greater than 0, it looks like a minus in here. If c is less than 0, it looks like a plus in here. And that is one of the things that screws us up quite a bit. Okay, so what we're going to look at quickly here is if I give you an example of what we got. So let's look at f of x turning into, so y equals f of x turns into, let's say, negative 2 f of 3x minus 6 plus 1. Well, before you can actually get all your transformations here, okay, you're going to need to look at this inside here and see that in order to get the right translation, you need to factor out that 3. Boom, there we go. Okay, so what's happened now is we can see that this is up 1. Okay, we can see that this goes right 2. We can see on the outside here, first of all, that it's a reflection in the y. So the y's change, so it's a reflection over your x-axis. It's also a vertical expansion of 2, and on the inside here it's horizontal, so it's a horizontal compression of 1/3. Okay, and those are all the different things. You have 5 different transformations that you have to do on this function. What is this function? It could be anything. It could be a quadratic, it could be a radical, it could just be some sort of inane shape that now you have to move up 1, right 2, reflect it over the x-axis, expand it this way by 2, and compress it this way by 1/3. Yeah, it's going to get a little complicated, a little convoluted, but we're going to do the best we can, okay? A couple things that we want to talk about here, things like invariant points, okay? These are points that don't change when you transform them. Mainly they occur on the axes, because if you have a value on the x-axis, say at x equals 2, and you expand it vertically, okay, it's not going to move. If this is your original function, it's just going to get steeper, but it's still going to go through there. So if you expand vertically, your x-intercepts don't change. Well, let's write that down. If you have a vertical expansion or compression, right, your x-intercepts remain the same. And if you have a horizontal expansion or compression, right, you have a horizontal expansion or compression this way, say, so you're stretching it this way, right, or compressing it this way, the ones that will not change are the ones on your y-axis. So your y-intercepts remain unchanged. Okay, so a couple things to think about there. Now let's have a look at an example. We will do some graphic examples for sure, but let me just grab a point here and say, okay, let's make a quick axis. Say that this here is a point on f of x. Okay, this is 2 and 1. So 2, 1 is on f of x. Okay, where is it on? Now let's make a complicated equation. Okay, negative 1/2 f of let's go 9 minus 3x plus 2. Well, let's have a look at this equation right here and see if we can rearrange it. So first of all, minus 1/2 f, I have to rearrange this. It's going to be minus 3x plus 9 plus 2. I can still go a little bit further here. I have to factor out a negative 3. It leaves me with x minus 3 plus 2. Now, it might not be a bad idea to identify everything that we're going to do, right? So this ends up being, what are we going to have here? So let's do the outside. Well, I guess what we need to talk about quickly here before we move on is the order in which we do these things, okay? Let me just find my notes here. There is an order. That's right. We have to talk about an order, okay? Once there are, let's do an order of transformations. We've talked about this briefly and looked at a bunch of examples. Mainly what I'm telling you to do, and I think you might remember, is that translations or slides last. Translations, slides last. Okay? Anything else you can do whenever you like, but the slides have to come last. Okay? Some people have their own order in which to do things, but let me just quickly show you why you have to do your slides last. So let's look at this final equation here. We got negative 1/2 f of, it's going to be minus 3, and then it's x minus 3 all squared plus, not all squared, sorry, plus 2. Now, if you can see that we have a vertical compression of 1/2 and a vertical slide up of 2. If I go up 2 and then take 1/2, I end up back at 2. If I take 1/2 and then go up 2, I end up at 3. Very different answers, okay? So slides come last. So let's mention what they all are. So a vertical expansion of, or sorry, compression, right? Vertical compression of 1/2. Flip over, this flips it over the x-axis, right? Because all your y's values become negative, so flip over x. Then looks like at the inside it is a horizontal compression of 1/3. It's also a flip over y-axis, that negative there. This means now that it goes right 3, and this means that it goes up 1. So we have 6 transformations that we're doing, and we're going to use this point right here to do them. So we start off at 2, 1. Vertical compression of 1/2. Vertical affects the x or the y. Vertical affects the y, so that becomes 2 and 1/2. You flip over the x-axis. You flip it this way. If you're flipping it this way, it's your y that changes. So now it's 2 and negative 1/2. Horizontal compression of 1/3. That means that you're, oh my God, you guys, I'm so sorry. Hold on, this isn't 0.21. I'm such an idiot. Okay, let's start this over. 2, 1, right here. My apologies. 2, 1. We're still going to start with 2, 1, which means that your y value will change. Yes, it's still 2.5. I just graphed it wrong up there, okay? Then 2 and 1/2 becomes 2 to negative 1/2. So we're down here now, okay? Horizontal compression of 1/3. So this is my horizontal value. 1/3 of 2 is 2/3. So it's going to be 2/3 and negative 1/2. And then it says flip it over the y. So your 2/3 now, which is here, flips over to this side. So now it's negative 2/3 and negative 1/2. And then it says right 3 and up 1. So right 3 means that you're adding 3 to negative 2/3, which ends up being 2 and 1/3. Let me just make sure here. Yeah, 1, 2, 3, 2 and 1/3. 1/3 and negative 1/2. And then it goes up 1. So negative 1/2 up to here. Boom, there we go. So you end up with 2 1/3 and positive 1/2. And that's your final point there. Whoops, I slid it all off. My apologies, guys. You can follow it through here. All right. I hope that helps. And if you have any questions, we'll deal with it in class. Thanks.